Hello. Today, we'll cover a fundamental concept in geotechnical engineering, the calculation of effective stress in soil. Let's start by understanding a practical problem. To recap, we'll be using the following steps to solve this problem. 1. Determine the appropriate unit weight of the soil mass. 2. Calculate the waterhead for each point in the profile. 3. Ensure the use of consistent units throughout the calculations. 4. Calculate or derive the appropriate equations needed for the analysis. Have a look at this soil profile. Our task is to determine the total stress, pore water pressure, and effective stress at points A, B, and C. Before diving into the solution, let's refresh our memory on some key terms. Total stress is the total downward force on soil, combining the weight of the soil and any external loads. Pore water pressure is the pressure exerted by water in the gaps, or pores, between soil particles. This pressure acts in all directions and can reduce the contact force between soil grains. Effective stress is the actual force that soil grains feel and transmit to one another. This is calculated as effective stress equals total stress minus pore water pressure. Now, for our problem, first, determine the appropriate unit weight of the soil mass. Using the given values, we have the dry unit weight as 100 pcf, saturated unit weight as 130 pcf, and water unit weight as 62.4 pcf. Next, calculate the waterhead for each point. This refers to the depth below the water table. Points A and B are above the water table, so they don't feel any water pressure. Point C, however, is 15 feet below. Always ensure to use consistent units. We are maintaining our units in PCF and PSF for this problem. Now, using our equations for total stress, pore water pressure, and effective stress, we can perform the calculations for each point. Here's a table summarizing our results. At point A being at the surface, all stresses are 0. At point B, we only have dry soil above it, so the total stress is due to that dry soil. At point C, we have both dry and saturated soil above, and it's below the water table. Hence, we have pore water pressure as well. And there you have it. We've successfully determined the stresses at each point. Understanding these concepts is crucial for foundation design, stability analysis, and other geotechnical challenges. Keep practicing, and soon these calculations will be second nature.